Okay, so we've got our cosine rule here. A squared equals b squared plus c squared minus 2bc cos a. Well, there it is. Bonk, bonk, bonk. Just draw it in again. A, B, C, and that there is angle A in there. Sometimes this is point A, and sometimes you refer to capital A as the angle, but it's the same idea. A squared equals b squared plus c squared minus 2bc cos A. Now, what I want to show you is we've got this nice rule here, and you'll remember that the derivation was quite complicated. We had to drop a perpendicular, we had to fool around with b minus that, we had to use Pythagoras, we had to cancel this, a whole bunch of complicated stuff. We're sort of using Pythagoras again and again and again here. So what I want to do is just to investigate the case. I'm just going to check what happens when A equals 90 degrees. So when A is a right angle, we better get back to Pythagoras. So let's have a look at this. Well, let's just write it in. There's A and B and C, and angle A equals a right angle. So the cosine rule tells us that a squared equals b squared plus c squared minus 2bc times cos of a, which is b squared minus b squared plus c squared minus 2bc times cosine of 90 degrees. Well, what's the cosine of 90 degrees? Well, here's my calculator. 90 cos. Cos of 90 is 0. There it is. 0. So it's b squared plus c squared minus 2bc times 0. And I've even got a picture of it here. Here's the cosine function. I set this up earlier. It's like Blue Peter, I guess. Here's the cosine function. It goes up and down, up and down, up and down. Cos 0 is 1, and cos 90, you can see here, is 0. Well, that's great. So what that means is it's b squared plus c squared with no correction. So a squared equals b squared plus c squared, which is just Mr. Pythagoras and his wonderful theorem. I want you to see what I've done. I've got this nice theorem, and what I'm doing is I'm playing with it. I'm just checking that it works in cases where I know something about it. I'm going to try another case here. I've got this triangle here. What I'm going to do is I've got the general case here. That's angle A in there. A, and which way around did I do it? B and C. I'm going to make angle A equal 0 degrees, which is kind of it's not really a triangle at all, but it's going to look like this. It's going to be so finely, it's not even going up at all. There it is, and there. So that's C. This distance here is A. Can you see I've just taken this triangle here and just flattened it down? And that's B. Let's see what the cosine rule says about that. Well, it says this. It says a squared equals b squared plus c squared minus 2bc times cos A. Observe how I'm always writing out the cosine rule again and again and again. I'm just checking I understand it. I'm just writing it out again. I've been using the cosine rule for 40 years, and I write it out again and again and again. It doesn't hurt, just write it out. Well, what's cos of 0? Well, let's get Mr. Calculator and ask. 0 cos, where's cos? It's 1. Well, we kind of knew that anyway from this diagram here. Cos of 0 is equal to 1. You can see it geometrically a little bit more easily. If you remember that if I draw a right angled triangle here, there's theta, opposite, adjacent, hypotenuse. Cos theta equals adjacent over hypotenuse, and if the triangle is kind of infinitely flat, then the cosine of this angle 0 here is adjacent over hypotenuse, which is 1. So cos of 0 equals 1. So what happens in the cosine rule? Well, we've got a squared equals b squared plus c squared minus 2bc times 1. So it's just minus 2bc equals b minus c squared. Because of course b minus c squared is b squared minus 2bc plus c squared, which is just this, just in a different order, that's all. So that tells us that a squared equals b minus c all squared. So a equals b minus c. Okay, actually it's plus or minus b minus c. There's two roots to that equation. Well, we kind of knew that. If this angle here is so small that this triangle is wrapped, this side comes cruising along here, and then it turns round on itself like a sort of like a hairpin bend. Well, a equals c minus b. Oh look, it's plus or minus b minus c because we didn't know which one was longer. I didn't tell it which was longer. B might have been longer than C, in which case the triangle would look like this. This is what we've got. We've got we've got C, B, A, and if B was longer than C, so in this case here, excuse me, in this case here, we've got A equals C minus B. But if that's A, if B was longer, then A would equal B minus C, wouldn't it? And of course, we haven't told the cosine rule which one's longer, but it still works. It's coming out with sensible answers, which is quite nice. So we get the cosine rule, and it checks out. The cosine rule is consistent. Cosine rule works when angle A equals 90 degrees because it just reduces to Pythagoras, and when A equals 0 because it tells us that it's either B minus C or C minus B depending on which one's longer, which is nice to know. Okay, I'm going to stop there.